Hi, this is Swathiramya, Assistant Professor, AIDS Department. In this video, we are going to discuss about the process and understanding the process concepts, which comes under the Unit 2 Process Management in Operating System and Virtualization. This topic is very important because every activity performed by the computer system is based on the process. Whether you open a browser, compiling a program, playing music, or even typing in a text editor, the operating system internally creates and manages the process. So, by understanding this topic, you are actually learning how an operating system brings a computer system to life. So, let's go into the slides. Process control block is so important because the operating system handles multiple processes at the same time. It must schedule the process, allocate the CPU, manage the memory, and perform the context switching from one process to the another process, track all the states of the process which is running in the backyard. Without storing all the process information, it is not at all possible. So for every process it has been created, it should have some record or the file. So that is how the PCB is. It has the details of every process. Whenever the process is created, PCB would have been created with that. Without the PCB, the operating system could not be able to run as successful as. So this is a storage, it is a data structure. As I told, it's a data structure maintained by the operator system. Now let us see what informations are stored inside this PCB so that you can able to understand why this PCB is very important. So let us see the structure of PCB. Whenever the process is created, I told PCB will also be created. So starting from its component inside the PCB, process control block, starting from the process ID. So whenever the process is created, every process will have unique process ID. Every process has a unique number that is called as a process ID. This helps the operating system identify each process separately, just like you all have the register number inside your college. Each process has PID inside the system. So two processes will not have the same ID at the same time. Like that, when you make admission in the colleges, you have your unique register number. Students will not have the same IDs. For two students will not have the same register number. Once you completed all these 4 years, this register number will not be given to anyone else. It has been destroyed. That is, the register number given for you is for yours. So once the process is done, these PCB will be removed, as I told you before. Okay, so this is how the PID, for every process you have the process ID. Next come the process state. As we see the process life cycle starting from the new, when getting into the new, when it started ready for the execution and it's waiting for the CPU, it will be in the ready state, then moving to the running state. It needs some memory or something else, so it will go for waiting state. We discussed all these process states in the previous class. So now you have to know this PCB will have the record of in which state the process is, right? So this process state tells the current condition of the process. Your process can be in a different state. It can be in the new, it is just created. New means it's just created already, waiting for the CPU time, running or waiting or terminated. It completes. So as you have been enrolled as a student and you are in the second year, right? So your record will tell you that you are studying in a second year or third year. So like that, this process state component will tell the process is in which state, whether new, ready, running, waiting or terminated. Okay, so this is how the process state information will be. Then about the third one, that is program counter. This is very important. As already we discussed, what is the program counter? Program counter will store the address of the next instruction to be executed. So imagine a process was running and suddenly CPU switches to the another process. When it comes back, how it knows from where it has to continue, because it switched from one place to another place, one process to another process. It doesn't know till where we executed the previous process. It should the previous state has to be stored in somewhere else, right? So when it comes back, it doesn't know where it has to start. So it checks the program counter. The program counter is the place where it stores where it has to start again. So it checks the program counter, which stores the stored in the PCB. Okay, so PCB will helps to resume the where it has to start. Okay, this is how the program counter, it has the instruction address, what is the next instruction to be executed.